Welcome back, students. So in this video we're going to look at sequences and series, particularly sequences on page 22. Okay, now what the idea is that when you get a list of numbers, if they can follow a mathematical pattern. Okay, so I've just added up two numbers here. Let's say they're random. They can be random. So we're going to start off with the simplest. Well, okay, let's be honest. The simplest series might be all the numbers are the same. Okay, so you might have 5, 5, 5, 5, and that might go on. Okay, 5, 5, 5, 5. So that's kind of boring, and we don't. That would be called a constant sequence. Okay, and it's pretty easy to guess or to calculate or to figure out what comes next. It's just going to continue on 5, 5, 5, 5, 5. Okay, so that's quite boring. Let's go with a new concept here. We're going to start with 5, but then we're going to use, so we go down here and we say we're starting off with 5, great. We're going to do a difference of 2, bringing it up to 7, a difference of 2, bringing it up to 9, and because this difference is common, we will call it the common difference, and that pattern will continue. Okay, so we're talking about sequences. Okay, we'll say, what are they all about? Numbers with a pattern. And then we're going to get into individual cases. So that's constant pattern with no difference between the terms. Okay, so we'll just jump in. If you're taking a note now along beside me, we call this here term 1, term 2, term 3, term 4, like that, and we shortcut that to term 1, term 2, term 3, term 4, etc. Okay, and we call the first, particularly for the first term, we use the letter A. So let's look at the log tables. Okay, let's go into contents and come down as far as sequence and series. That's informing us. Straight edge to carefully be organized, and we're going heading over to page 22. Page 22. Okay, so let's see what we have here. We read it carefully. Sequences and series. In the following, this is pronounced term n is the nth term, and Sn is the sum of the first n terms. Let's just get the first bit written down. So I want you to dictate this down. You can open your log tables on page 22 and write. We'll start, we won't say in the following, we will just say term n is the nth term, full stop. Okay, the nth term, it's a general term. Now what we're looking at here is a formula for the type of sequence I've just shown you, which is a linear sequence. Down here we have a geometric sequence, and what isn't shown here at all is, and we come back to these formulas and try to make sense of them, or at least this one, and later on this one in a different video. A quadratic term is not shown here. I'm going to try and cover that on this video as well. Okay, let's drive on with this then. So in terms of, so here, if n is 1, so we'll ignore the formula for a second and just get back to our example sequence first. Example sequence 5, 7, 9, and 11. Okay, so a very common question is write down the next, normally 3 terms, the next 3 terms. Okay, so you keep adding on your common difference of 2, and you'll come along here. I'll just use pencil to write in my answers. 13, 15, 17, and that continues forever. Okay, what is A, the first term, term 1? And A is, so term 1 equals 5, and we have a special letter for that, we call it A. So A equals 5. What is D? We introduced a variable D, the common. That's only common in linear sequences. In quadratic it won't be common. It'll keep changing. What is D? The common difference. Okay, and here D equals 2. Okay, now we're going to try to visualize in a graph. Now the thing is, x-axis turns into the n-axis in our graph, and all a sequence is a function that is not continuous, it's discrete. Okay, for example, at term 1, we call this 1, we're getting 5, then 7, then 9, etc. Now because we're going up the same amount, with the same slope, we get a straight line, even though it's only the dots or the values, but we can use the straight line to think about our other values. Okay, and the slope of the line is A, the common difference, D, the common difference, and 1 goes here. And this number here is A. Okay, so a quick trick. So what we want is we don't want to recursively be able to calculate only the next term. So if I said to you, what's the 20th term now? You may say, well, I'll just keep going up as far as 20. But you'll have to agree that's a little bit cumbersome. So what we want to do is we want to come up with what's called the general term n. Now that is done for you here in the tables, and I want to make sense of this. They're saying start with the first term, A, which is here, and add on the difference. Let's say I've added it on once, I've added it on twice, I've added it on 3 times. But I want you to notice, at term 2, you've only added it on once. At term 3, you've only added it on twice. So at term n, you've only added it on n minus 1. So that's why there's an n minus 1 there. And you can use this formula, and I'll certainly do questions with that formula, but there is an easier method, and it is all to do with the fact that in sequences, the first term is term 1, not term 0. But if we bring it back to term 0 here, okay, term 0, we have a much easier way of calculating term n. So it goes like this. Well, what is term 0? Let's put it in a box here. We can just look at the pattern coming from right to left. So the pattern is take away 2 and take away 2. So I'll get a 3 here. And then I can exploit from our coordinate geometry. Term n is like y. N is like x, and you will remember we can go y equals mx plus c, the equation of a line, where c in our case is term 0, y is term n, d is m, and this is n. Okay, so we get like this. We can easily get term n by just using the number d and the number term 0. Okay, so we'll be doing a full example real quick now in a minute, but we've got 3 here. So when I'm working out term n, I can say, sorry, my mistake, this is the common difference. So basically the common difference is 2 going up 2 and going up 2 every time, and I'm starting off here at 5 on my graph. Okay, so once you've calculated that common difference, later on it'll be called the first difference when we're doing a parabola, but right now it's term n equals 2n plus 3, and that's our first question done. as such, in that you can solve lots of things with that subsequently. Okay, so I'll just put this up as the first video. I'm just going to do one more example, but then we'll get into a practice video. We've got to make the videos kind of spread out enough. Let me just enlarge this a bit for you. That'll do. Okay, again, let's go with an increasing video and increasing linear sequence. So let's go start with 7, add 3 to 10, add 3 to 13, ... Okay, and we go straight into calculating term n, because it's the most, it's the most difficult part of these questions, is calculating the general term. Okay, so what do? You start here underneath the first comma, and you go 10 subtract 7. If you needed to use a calculator, if minuses come into it or anything, you can do that. You do 13 subtract 10 is 3. Okay, and at that stage you can be sure that the 3 is continuing on, so you can say, okay, 16, 19, 22 are my next terms. Add 3, add 3, add 3, etc. Okay, and you can go term n, and you can say, once you've that done, you can write down the n term of term n. There's 2 terms here, and then you can, so that's that, and then you can come up here and say what term would go there, and say, sure, I'm going to take away 3 from 7 and get 4. And that's a very quick way, without any algebra, of getting that. You could, through 2 other methods, you could go term n equals a, you could use the formula a plus n minus 1d. You can say, okay, well, in that case, term n is 7 plus n minus 1 times 3, and I'll put the 3 in front here. Okay, after distributing the 3 multiplication, you'd get plus 3n minus 3, and then you'd get 4 plus 3n, and there you go, but sure, that's term naught. Another trick here is, very quickly, is to double the 7 and take away 10. We'll give you this. If you don't want to work out the common difference and then subtract it, you can double the 7, 14, take away 10. Okay, so what variations can we have? Well, we can climb by larger than the first term, which will cause this to be negative. Okay, for example, if I go on by 6 and by 6 and by 6, I'm going to be getting 6 here. By the way, as well as this being called a difference and common difference, it's also called a first difference, because later on in a different type we're going to be taking a second difference. So 6, 6, 6 is a constructed sequence from differences. Okay, and if you're asked what type of sequence it is, and you get this constant of any value, 6 or 3 or anything, you would say it's a linear sequence. Another word for that, it's a arithmetic sequence, and you're going to justify that. You have to justify it. You will always be asked to justify it, because the common, or we call it the first difference, by the way. The first difference, you could say, is common, meaning it's not changing, or you could say the first difference, d equals 6. Okay. Continuing on with this, double 4 is 8, take away 10, or 4 take away 6, either way you get negative 2 for term naught. You get term n equals 6n. Use this first in front of n, then use this as a constant. I'm going to leave it at that because we're up to 10 minutes, and I will see you in the next one.